Welcome to another Hopper internals video. If you don't know what Hopper is yet, I suggest you look at some of the more high-level videos on my channel. Getting right to it, this video is about inlining Hopper opcodes within a Hopper program. It's a feature I used so that I could implement a basic interpreter on the 6502 where the basic interpreter was tokenized to use the Hopper virtual machine directly, which made it super efficient. By way of example, I'll load up basic in my debugger. So this is my debugger. If you look at the bottom left of the screen, it is uploading. It's finished uploading Gibble, which is Gordon's tiny basic written in Hopper. It's uploaded to my 6502 machine. I'll hit F5 to run it. This is the serial console on the top right. So that's currently on the 6502 machine. Let's put in a little program quickly. Something we've all seen before. And let's run it now. So I'm in debug mode. If you look on the left here, I've got debug defined. So I get diagnostics. This is how long it took to tokenize each line in milliseconds. And there's the output of the program. In addition, when I'm in diagnostic mode, in debug mode, if I say list, in addition to the lines, it's going to show me what it tokenized each line as. So you can see the Hopper bytecodes that are on the virtual machine that is currently running for these. So the for I, it's initializing a variable to this global variable 28 to 1, putting a 1 in it. This is what's doing the print. So this syscall here, this call over here is actually calling back to the runtime to do a print, etc. So let's switch back, wondering what I can do with that. Yeah. Okay, so I'll Control C out of that. Let's go see how it's implemented. Let's Alt F4 to get back to the editor. It's all based around this inline method in the Hopper runtime and in the system runtime. And it's not really inline. It's actually, you just say here's an array of bytes executed as if it was Hopper opcodes, and that's it. And index is the start address. So you can use that to jump to, to go to a line in the middle of your program if you wanted to. So that's how it's inlining. Let's go back to this Gibble basic interpreter. There's two important parts to it. I'll show you the runtime first. So you don't want to write everything in assembler when you could write it in a high-level language. So in the runtime, I've got some callback methods that are hooked to delegates. Delegates are, what C# calls function pointers. So I have some obvious callbacks here, things to do random numbers, things to do printing. Where's the print ones? Why don't I see the print ones? Because I'm right at the bottom here, print. Yeah. So these are callbacks to Hopper functions to do the printing. Let's go look at the printing one and see what it does. It's probably... There we go. Yeah, so printing's not, just writing a string, taking a string from the stack and writing it. That's as complicated as printing is. These are the random number ones. Callback functions in Hopper that can be called from the bytecode. So this is the one thing. It's called runtime. And then the other one, Hopper code. And Hopper code is what the parser will call to generate code. So the parser calls an append code method to add instructions. If we go on, we'll see some more interesting ones. So this one here, a divide by zero check. This one here is negate. So it takes what's on the top of the stack and subtracts it from zero. So this is how you negate an integer. You push zero onto the stack, you swap it with what was already there, and you just called the signed addition. And it's pushing these into that, if we go look at what append code does, it's pushing them into that array. So just adding instructions to the array, and then when it's time to run them, it's calling that inline method, saying, here's my array, this is where I want to start, off you go. So that's the long and the short of it. There's a small complication with BASIC, and that involves fix-ups. I wonder if I could find fix-ups easily. Where you don't know what the address of a goto is at compile time, for example. So in BASIC, you can go to an expression. So that's like in Tiny Basic, it's just go to expression. In the other basics, it's called on goto. So you don't know at compile time or at tokenizing time what the address is. So it calls a function to resolve that, to take whatever the result is of the expression, go look it up in a table of line numbers, which are then indexed back to what the actual address is for each of those line numbers at runtime. That's what so that's the only complex part of implementing this for BASIC was the patching for making dynamic gotos work. The rest was fairly simple. I think that's enough of an internal on this for now. Yeah. Please give me feedback if you want more detail or less detail, or if there's a more interesting angle we could take or direction this could lead to.